Hello everyone, welcome to the fundamental introduction of the Bewischen series image analysis. I am Wei Chenggan, a better science application engineer. As an early access user and a developer of the Bewischen series, I would like to introduce the newly updated Bewischen series to you. Today, we will begin with the working principle of the Bewischen series, the image analysis method. After explaining the fundamental concepts, we will take a glance at the whole series, introduce the overall performance and software of the Bewischen series, and choose the right Bewischen for you. Then, we will get to know every family member of the Bewischen series in detail, and going through the Bewischen S1, M1, and D2, and introducing their features, benefits, highlights, and applications. Let us dive into the image analysis method first. Among these particle sizing technologies, the image analysis method of particle sizing or microscopy analysis technology can measure the size of a wide range of particles, from a few microns to several millimeters. The term image analysis is describing a mechanism. The image analyzer will capture an image of a 3D particle first, then do the analysis based on the 2D particle projection image. The digital image is made up of pixels of the same size and shape. Through the calibration process, we can get to know the actual size of a single pixel and the area. Then, the total size and shape of the particle projection can be easily measured. The size and shape of the 3D particle are measured in this way. During the whole process, particles do not contact any probe. That is why we call it a contact-free method. The image analysis method is non-destructive, so it is possible to recycle the samples after measurement. Now we have got the size and the shape of a 2D projection. How can we use it to describe the size of the 3D particle? The main method is to describe the size with an equivalent diameter. The equivalent diameter is the diameter of a sphere that has the same parameter as the particle. It is used by many particle sizing methods, for example, the laser diffraction method, the dynamic light scattering method, and of course, the image analysis method. The image analysis method can measure the diameter of a sphere that has the same projection area as the particle, which is called area equivalent diameter, just like the picture we showed here. Similarly, the perimeter equivalent diameter is the diameter of a sphere that has the same projection perimeter as the particle. The area equivalent diameter XA is the most widely used sizing result of the image analysis method. Besides, the image analysis method also provides other size parameters based on the particle projections. For example, the Ferret diameter, Martin diameter, and Legendre diameters. The Bewischen series of particle image analyzers can offer every parameter we mentioned here. The particle projection not only provides information about the particle size, but also the particle shape. The image analysis method describes the shape of particles in the form of different shape parameters. Some of them is describing the size difference in two directions. For example, here we have the LW ratio is the ratio of the length of the minimum particle bounding rectangle to the width of it. Another example is the irregularity, which is the ratio of the maximum inscribed circle diameter to the minimum circumscribed circle diameter. Any particles with bulges sharp corners, etc., will have a low irregularity value. The more particle projection shape similar to a circle, the closer the irregularity value is to 1. For elongated particles, or particles with a concave contour, there are some parameters to describe their shapes, such as convexity, elongation, and straightness. Same as size parameters, all parameters mentioned here can be measured with a Bayesian image analyzer. In most applications, people care about the size and shape distribution, the PSD, of the whole sample. As we discussed, the image analysis method provides the size and the shape of individual particles. With the single particle data, image analyzers sum all the particles up and do statistics, thus generating the PSD. Distributions generated by summing particles up are called number distributions or number weighted distributions. Here we got two particles. The one is 1 micron large and the other is 10 microns. As shown in this picture, the number distribution weights concentration by number, so each particle is 50% of the whole sample. In comparison, the 10 micron particle concentrates 99% of the whole sample in the surface distribution, and it concentrates 99.9% when in the volume distribution. As a reminder, all three types of distribution are correct. They just describe the PSD of the same sample in different ways. However, different particle sizing methods provide results in different distribution types. To compare results of the image analysis with the other methods, the Bayesian series offers a convenient transformation function. Users can transform the display distribution type of a sample easily. Now we have known how the single particle data forms a PSD in the image analysis method. But what does that mean to us? The first benefit is the high resolution result. In a number distribution static, content differences small as one particle will be loyalty presented with the PSD curve. In this way, oversized and undersized particle sensitivity is ensured. The smallest amounts of undersized particles or oversized particles can be detected and presented. For example, 40 microns glass beads and shards are undersized particles. In comparison, those 70 microns beads are oversized ones. Usually, these particles with unconventional sizes are unwanted or unqualified. So, image analyzers are widely trusted by QC engineers from different industries. Another benefit provided by the image analysis method is the particle scatter plot. Since the image analysis method calculates the size and shape parameters of every single particle, it is possible to do a scatter plot to present the relationship between the particle size distributions or particle shape distributions. On a scatter plot, each point stands for a single particle, and the x and y axis is a size or shape parameter. From the scatter plot, we can easily locate particles with special size or shape characteristics. For example, a size circularity scatter plot here can help us find those particles with large size and circular shape, or particles with smaller size and non-circular shape. The scatter plot also helps us understand the chain of particle size or shape distribution of the sample and identify impurities or undesired particles. In summary, why do we need the image analysis method? The first thing is the image analysis method is easy. It is easy to understand and easy to apply. Secondly, the image analysis method provides both size and shape results. Today, particle size alone may not be sufficient to get qualified products out the door. Many industries are turning to particle size and shape analysis. This is where the image analysis method comes in. Thirdly, as we mentioned, an image analysis test is a contact free test, also a non destructive test. It does not harm precious particles. Most importantly, the image analysis method produces reliable results. From the size and shape of individual particles to high resolution size or shape distributions. The image analysis method helps users from different industries to develop an insight into materials. The image analysis method is divided into two kinds. The one is dynamic image analysis method, the DIA, and another is the static image analysis method, the SIA. The difference between the two methods lies into the movement state of particles. During the DIA test process, the particles keep moving, passing the camera, and the camera captures particle images. But for the SIA test, particles do not move when the camera is capturing the image. Now, we have two different image analysis methods. What are their features? How could we benefit from these methods? Okay, let us dive into the SIA method first. The static image analyzers combine precise microscope with a high resolution camera. It is possible to capture a highly magnified image and keep it clear without any blur or distortion. Also, based on features of the image analysis method, a static image analyzer can easily detect undersized particles or even estimate the size of tiny undersized particles. Another benefit of the static image analysis method is the small particle volume requirement. A few drops of emulsions or a few microgram of powders are enough to do an SIA measurement. But there are some drawbacks to the SIA method. On the one hand, the total number of measured particles is limited. As shown in this picture, if we take those particles in the red circle as the sample, we will miss the large particle and produce a wrong particle size distribution. Also, when we are measuring some flat or flake-shaped particles, particles may overlap each other, as shown in the red box here. Since we are calculating the particle size with the projection area, particle overlapping will affect not only the accuracy of the sizing, but also the accuracy of the particle number counting. Fortunately, if we correctly prepare the sample, the particle overlapping can be avoided. When we turn to the dynamic image analysis method, its first benefit is efficiency. A large number of particles swiftly flow through the measurement zone of a dynamic image analyzer, accelerating the measurement process. Also, based on the large particle number, the statistical significance of the DIA method result is enhanced. Another benefit of the dynamic image analysis method is the oversized particle sensitivity. It is possible for a dynamic image analyzer to estimate the size of some oversized particles. Before we discuss the large particle measurement, I would like to share something about the motion blur. The motion blur or shading phenomenon will cause a dynamic image analyzer captures blurred particle images. The good news is we can solve this problem with optical settings, for example, high-speed cameras and stroboscopic light sources. On the other side, when the particle size becomes larger, the negative effects of the motion blur become smaller. That explains why the dynamic image analyzer is a good choice to measure the size and shape of large granules, such as coffee beans and silica gel desiccants. In comparison, static image analyzers could observe particles with higher magnification, and static particles reduces any potential blurs or distortions. Besides, the SIA method requires less sample volume for one test. When the sample is very valuable, we should employ a static image analyzer to do measurements. With the image of particles, the SIA method is a perfect choice to do cross validation of other particle sizing technologies. For example, if we find some extra large particles in the result of a laser diffraction particle sizer, we can use a static image analyzer to judge whether those large particles are bubbles or agglomerates. The DIA test is more efficient and measures tens of thousands of particles in the test. The large particle numbers helps the DIA produces more reliable statistics and more reproducible measurements. With its efficiency and reliability, the DIA method is widely used in particle size and shape measurement of bulk materials, such as ores, cereals, and plastics. Now we have got enough basic knowledge of the image analysis method. Let us take a step closer to the Bevision series. The Bevision series image analyzer is made up of three models: the Bevision S1, M1, and D2. The Bevision S1 and M1 are static image analyzers, and the Bevision D2 is a dynamic image analyzer. On the other hand, the Bevision M1 and D2 have automated hardware, which makes them possible to do measurements automatically. The Bevision image analyzers aim at different applications, and they have different measurement performances. Firstly, their measurement range is different. Static image analyzers perform better for fine particles, but they have a lower max size. Here, we can find the Bevision S1 measurement range is from 1 micron to 3000 microns. In comparison, the Bevision D2 measurement range is from 30 microns to 10,000 microns. However, the Bevision M1 has a very special range, covering from 1 microns to 10,000 microns. Wondering why? No worries, we will discuss this in the later part. As image analyzers, all three models of the Bevision series provide accurate particle shape analysis, high-resolution results, and individual particle analysis. Following the difference between two different kinds of the image analysis methods, the dynamic image analyzers, which is Bevision D2, can accurately analyze samples with a broad PSD, and the reproducibility is better. Comparatively, the static image analyzers require a smaller sample volume and are more sensitive to undersized particles. Besides, the image analysis process is simple, and the Bevision M1 and D2 employed automatic hardware to make the test process easier and faster. As previously mentioned, three Bevision image analyzers aim at different applications. Accordingly, we prepared some questions for you to help make a choice among the Bewischen series. For example, based on the measurement type, you can choose the Bewischen D2 for dry and free-flowing coarse particles. Or if you are looking for filter inspection tool, then the Bewischen M1 is the best choice among three Bewischen image analyzers. Most importantly, if you want to reduce your workload with automatic hardware, then you should try the Bewischen M1 or Bewischen D2. As we know, the image captured by image analyzers should be analyzed by the software, then produce the single particle sizes, shapes, and statistical results. The Bewischen software is the brain of all three Bewischen image analyzers. From starting the test to analyzing the result, it manages every step of the test. Besides, the brand new interfaces can help you to organize test records and present the results. If you are a Betasizer user or Binano user, you must be very familiar with these interfaces. When analyzing the particles, the Bewischen software will measure 24 size and shape parameters of each particle. Also, the Bewischen software provides highly customizable reports to present size and shape distributions of the sample. An automated particle size or shape measurement is a combination of automatic hardware and a set of standard operating procedures, an SOP. Automated measurements can help improve working efficiency and to produce more reliable results. The Bewischen software provides the automated measurement function, also called the SOP test function, to users. In the Bewischen software, a complete set of SOP settings is made up of two parts. The first one is, of course, hardware control settings that guide automatic hardware, such as camera parameter settings, automatic stage moving of the Bewischen M1, and feeding rate settings of the Bewischen D2. Another part is image processing settings, which recorded how the Bewischen software processes the image captured by image analyzers and how to identify particles from the raw images. An automated measurement can help operators reduce the workload and test time and produce reliable results in a standardized way. Here, we show two members of the Bewischen series. The left one is the Bewischen M1. All you need to do is load the slide with the dispersed samples onto the stage and click the Start button in the software. The one on the right is the Bewischen D2. In the SOP test mode, just add samples through the feeding funnel, click the Start, and wait for the results. As we mentioned, SOP settings are of vital importance for automated measurements. Can we measure different samples with different SOP settings correspondingly? How could we generate a set of SOP settings appropriately? The Bewischen software provides the following functions to help you manage SOP settings and accelerate your test. As basic management, the Bewischen software prepares a database for SOP settings. It is possible to create new SOP settings, edit present SOP settings, and delete. When starting a new test, you can select a set of SOP settings from the database. With the database, you can save a set of SOP settings for every kind of sample, and we recommend doing so. Advanced SOP management functions are prepared for something different. Assume we just make a manual test and save the test record successfully. Now, it is time to make the test procedure a new SOP. What should we do? All we need to do is get SOP settings from the test record and save it as a new set of SOP settings. As we mentioned in the former parts, image processing is a key part of the image analysis process and also an important part of the SOP settings. The Vision software offers the function of exporting and importing image processing sequences, helping us to get highly consistent results even with different image analyzers. The SOP settings help us make a satisfying test. How can we organize the data and statistics into readable graphs or charts? The result presentation page of the Vision software provides 5 powerful weapons to present test results. The first one is the particle size or shape distribution curve here. This graph is presenting the PSD of the whole sample. You can select from a differential curve, a histogram, and under sieve cumulative curve, a sieve cumulative curve, or even display all of them. The second one is a scatter plot. It describes the relationship between distributions of two particle size parameters or shape parameters. Every point on the scatter plot, as we discussed, corresponds to a particle. The third one is particle galleries on the bottom. Here, we got two galleries, the single particle gallery and the one for connected particles. If we select some particles from the gallery, we will find the corresponding point in the scatter plot is highlighted. Here, we select the number 7042 particle and there is a highlighted dot here in the red circle. When we select a particle, its properties will displayed here in the single particle properties chart. The properties including the ID, area, perimeter, and diameter and shape parameters. More importantly, we would like to know the typical value of the PSD. They are displayed here. You can see the mean values, maximum value, minimum value, D10, D50, and D90, and so on. Also, you can check the content of every interval in the distribution table, or view the single particle data in the corresponding table here. The Vision software also permits comparing different results. You can compare the distribution curve, distribution table, and scatter plot of multiple test records. A comparison can check the product quality or help you with comparing the SOP or even evaluate data reliability. There are still many potential applications of the result comparison function waiting to be discovered. We will share those new ideas in the future application notes. Now, we have done an automated test. We have organized the results in wonderful charts and graphs. And it is time to make a strong finish with a report. The newly designed beta-size report has the following advantages. It has complete and detailed data, it is fully editable, and also you can switch the formats of reports freely among the PDF and image files. Now, let us get to know about the Vision S1. The Vision S1 is a classical static image analyzer that offers an easy solution to measure and analyze the size and shape of particles in a range of 1 to 3000 microns. There are three optional models of the versatile Vision S1 for different applications. All of them are easy to use while staying reliable and accurate. Just like every member of the Navision series, the Navision S1 is equipped with powerful software. The Navision series offers 24 different particle size and shape parameters and further organizes the data into an all-around validation of particles. Our results comply with the ISO 9276 standard. Navision S1 is not only a budget-friendly particle size and shape analyzer, but it can also be a perfect match for laser diffraction particle analyzers as an aid or as a verification. Why is Navision S1 a good choice for you? Let's see how it can help. Firstly, with the help of the Navision software, the Navision S1 is an effective tool when doing particle size and shape measurements. As we discussed, the SOP of image processing and particle analysis can easily work. On the other side, the Navision software helps to make the Navision S1 a comprehensive validation of particles. Secondly, the Navision S1 is accurate. It is calibrated with certified graticules and passed the certified reference materials test. Besides, the Navision S1 has multiple optional models, which makes it versatile. Most importantly, you can enjoy all these benefits with a friendly budget. As a classical static image analyzer, the working process of the Navision S1 includes three steps: dispersion, imaging, and processing and analysis of the image. The dispersion is to disperse particles apart and prevent the particles attach. It can be done by keeping the particles dry or wet. A BT910 dry powder dispersion module can help you with this step. As for the imaging part, the optional models of the Navision S1 differs in the light source modes. We will discuss it later. This picture is showing the design of the standard model of Navision S1. And all these models are equipped with a high resolution camera to capture high quality images. When it turns to the processing and analysis of the image, the Navision software will help the Navision S1 automatically do measurements of particles in multiple fields of view. The results will sum up and form a statistic. The standard model of the Navision S1 is equipped with a transmitted light source. It can observe and analyze particles effectively for most applications, such as minerals, chemicals, ceramics, and polishing agents. The optional reflected light source of the Navision S1 can help measure particles dispersed in opaque mediums or on opaque surfaces. For example, particles on filter paper or filter film, and metal powders embedded in metallographic samples. The Navision S1 polarizing mode provides users with particle size and particle shape analysis under polarized light. The polarized light model Navision S1 is trusted by researchers and engineers in the field of biology, pharmaceutical, geology, etc. The BT910 dry dispersion module aims to offer a reliable and reproducible dispersion method for dry powders. To prepare samples, the BT910 will create airflow with air pressure difference, and the airflow break up the aggregates, reduces the sticking between the particles, drive the particles moving into random directions, and spread particles evenly over a glass plate. The only variable during the whole sample preparation process is the air pressure difference. Thus, Repeatability of sample preparation was ensured with the controlled pressure difference. Navision S1 has been proven efficient and reliable in many industries. For example, Navision S1 offers both size and shape evaluation of abrasives, helping the users build an insightful validation of the quality of abrasives. Also, Navision S1 offers help to researchers in the field of biology research, geology study, and pharmaceutical research. The figure on the left is quartz sand particles, and the one on the right is a set of images of lipid microcapsules. According to our customers, the Bevision S1 is so versatile that you can take advantage of it no matter where you need a microscope to observe particles. As we discussed, microscopic images provided by the Bevision S1 are persuasive support for the particle size distribution results of other sizing methods. Here, the particle size distribution curves from Betasizer 2600 show the chain of the particle size distribution of polishing agents samples A, B, and C. Images taken by Navision S1 prove that there are small amounts of oversized particles within the sample B and sample C, becoming the strong supports of the PSD results from the Betasizer 2600. Navision S1 is a convincing tool when evaluating particle size results, and also a handy tool to ensure product quality. Now, let's turn to Navision M1 and see what is the unique features and benefits of the automated static image analyzer. Navision M1 provides an accurate analysis of the particle size and shape in the range of 1 to 10,000 microns. Besides, Navision M1 can be a vital part of the surface cleanliness test. Thanks to the auto-moving stage with high position accuracy, Navision M1 can do analysis more efficiently and go beyond the size limit. In coordination, a high-speed camera captures images with high efficiency. We will discuss more on how Navision M1 breaks the limit later. Same with Navision S1. Navision M1 is equipped with powerful Bevision software. The Bevision series offers 24 different particle size and shape parameters and further organizes the data into an all-around validation of particles. All the results are in compliance with the ISO 9276 standard. With the help of the Bevision software, the Bevision M1 pushes the efficiency of static image analyzers to the next level. Utilizing the automatic stage, the Bevision M1 has two auto measurement modes. One is scanning mode, and the other is the panoramic mode. The scanning mode is so effective that it is possible to measure thousands of particles within a few minutes. And the panoramic mode can help present a microscopic region with keeping microscopic details for particles, so it is widely used in filter inspection. Same as Navision S1, Navision M1 is also accurate and helps to make a comprehensive validation of particles. Every instrument of the Bevision series is calibrated with certified graticules and passed the Certified Reference Materials test. The workflow of the Bevision M1 scanning mode is to capture an image first, then analyze the image while moving the stage, capture the next image once the stage has reached a new position, and repeat. The Bevision software will display real-time results during the scanning process. The scanning mode is widely welcomed in different industries with its efficiency and reliability. With the help of the SOP settings, the automatic scanning process improves the task efficiency, doing the image capturing and stage moving simultaneously pushes the efficiency to the next level. The efficient scanning mode analyzes many particles in one test, thus strengthening the statistical significance of the result. Different from the scanning mode, the panoramic mode is to stitch separate images into a panorama before analysis. With a panorama, it is easy to measure the total number of particles in the region and the size and shape of every particle. The accurate particle number is of vital importance to different industries. For example, the automotive industry and the pharmaceutical industry. Even if the particle is cut by an edge of a single field of view, or it is an oversized particle larger than one single field of view, its size and shape can be successfully measured with a panorama, just like the blue particles here and here. That is why the Bewitch M1 has a maximum size of 10,000 microns. Panoramas produced by the Bewitch M1 recorded all particles dispersed in the millimeter level region and keeps their shape details. A clear panorama helps to accurately count particles in the macro region and analyze the size and shape of particles without any leftovers. Thanks to two different modes, the Bewitch M1 goes beyond the application's potential of traditional static image analyzers. The scanning mode is a high-efficient and automatic version of traditional static image analyzers. Thus, it can be employed in industries that require SIA analysis of a large number of particles, such as abrasives and mineral pigments. In comparison, the panoramic mode is less efficient, but has higher accuracy for counting particle numbers. And more importantly, it is describing a large region and still keeps every microscopic detail of it. Thus, the panoramic mode plays an important role in two ways: observing large-sized particles, such as fibers, or observing large regions, such as filters. The mineral pigment is a type of pigment derived from ground ore. The size and shape of mineral pigment particles affect the quality and performance of paint products. Selecting the scanning mode, the Bewitch M1 is able to offer reliable size and shape measurement results with good efficiency, helping the QC engineers achieve an insightful validation of mineral pigments. Here, a scatter plot showing the relationship between particle size and circularity helps compare the shape distribution of the grass green pigment and the coffee red pigment, and guides designing paint recipes. Also, particle images from the single particle gallery provide a direct way to check particle appearance. In the next part, we will take a closer look at the dynamic image analyzer, the Bewitch D2. The Bewitch D2 provides an efficient solution to analyze the size and shape of dry, high flowability powders or granules. Tens of thousands of particles can be measured by a Bewitch D2 within 3 minutes. Combining a high-speed camera with a precise telecentric lens, the Bewitch D2 is able to effectively analyze the size and shape of particles in the range of 30 to 10,000 microns. Besides, An automated feeding system helps Navision D2 run effectively. Same with other family members of Navision series. Navision D2 is equipped with powerful software. Navision series offers 24 different particle size and shape perimeters and further organizes the data into an all-around validation of particles. All results are in compliance with the ISO 9276 standard. Utilizing the automatic feeding system and high-speed camera, the Navision D2 can measure the size and shape of particles with maximum efficiency. Besides, the sample recycling drawer can help you recycle samples after a quick test. Same as other members of the Navision series, the Navision D2 is accurate when keeping efficient and helps to make a comprehensive validation of particles. Every instrument of the Navision series is calibrated with certified reticules and pass the certified reference materials test. To measure the size and shape of particles over a great variety of applications, the Navision D2 has equipped with a comprehensive range of hardware. Now, let us follow the particle traveling through the Navision D2 and get to know how the Navision D2 work. In the beginning, the particles are added to the feeding funnel and stored there. When we click on the Start button in the software, the feeding chute starts to vibrate and send the particles into the Navision D2. The customizable coating material for the funnel and chute can effectively prevent particles from sticking to the wall. The size of the funnel and chute are also customizable based on the requirements, permitting the Navision D2 to hold an appropriate volume of samples. Going through the adjustable feeding guide, particles enter the Navision D2. Depending on the approximate particle size and the width of particle size distribution, the Navision D2 offers 5 optional objective lenses to ensure the result accuracy. Each optical lens has its own efficient working range to accurately measure particle size and shape of a great variety of samples. It is worth noting that corresponding to the sample material properties, selecting the best hardware can help measure size and shape of particles with optimum accuracy and efficiency. The hardware of the Navision D2 is utilized for measuring dry granules with a wide PSD. The automatic feeding system, which makes up of the feeding funnel and the chute, can disperse and transport the dry granules in the most appropriate manner. Combining the feeding system, high-speed camera, and powerful software, the Navision D2 can help measure the particle size and shape with excellent efficiency. Tens of thousands of particles can be measured within 3 minutes. Also, results produced by the Navision D2 have a good fit with the results of other particle sizing methods. For example, the box-wise and minimum ferrite diameters in volume distribution fit the sieving results well, and laser diffraction results are in good fit with the volume distributed XA results. As we formerly mentioned, the Navision D2 aims at measuring the size and shape of coarser and wider distributed dry granules. It is widely used to analyze minerals, abrasives, plastics, and resins, etc. Here shows some images captured by the Navision D2. The left one is of absorbent material particles, and the one on the right is of natural sands. Also, the Navision D2 is well trusted for its efficiency. For example, the Navision D2 can be used to analyze the particle size and shape of metal powders used for 3D printing, also known as additive manufacturing. Silica gel beads can be used as a desiccant, or we said drying agent, superabsorbent materials, stationary phase in chromatography, food additive, etc. In general, the silica gel beads should be in narrow monomodal size distribution to ensure even absorption of moisture. Their shape should be round to maximize the relative surface area for improved absorption. So, measuring size and shape distribution of silica gel desiccant products makes it easy to find out the concentration of broken or deformed particles and evaluate the size distribution of the product. Okay, we just walked through all the sections in this presentation. We discussed the image analysis method for particle sizing, the dynamic image analysis, and the static image analysis. Then we get to know about the Bewision series of image analyzers in total and in detail. Thanks to the powerful hardware and software, the Bevision series is able to navigate all the challenges of particle size and shape analysis you may meet. Remember, a picture is worth a thousand words. This is the end of this presentation, and I hope you find this video helpful. Please be sure to leave any comments or questions below and check out the Better Size website for more product information. Thanks for watching.